Okay, so we're going to do a little review of end behavior and turning points. There's some nice diagrams in the book explaining end behavior, and we've talked about it before, but it's based on two things for the leading term. So if you have f of x equals a sub n, x to the n plus, and then you have some other terms there. End behavior, just make kind of a little rough chart here. If n is even, and if n is odd, that will affect end behavior. And remember, n is the exponent here. And if the leading coefficient is positive, so a sub n is the leading coefficient, if it's positive, or if the leading coefficient is negative. Well, if it's positive and it's even, then they're both going to be going up to the left, up to the right. If the leading coefficient is negative, but n is even, then they're both going down, down to the left, down to the right. If n is odd and the leading coefficient is positive, then it's going to be down to the left, up to the right. And then finally, if the leading coefficient is negative and it's odd, it's going to be the other way, up to the left and down to the right. Okay, so that little chart might help you remember end behavior. I never think the textbooks make a big enough deal about end behavior, but that's what you need to know when you're going to sketch the graph. That's what you have to know to start to draw it. Okay, now turning points. Turning points. The maximum number of turning points, maximum number, is n minus 1. So if n is 6, you have a degree 6 equation. You can't have more than 5 turning points, okay? So remember that. It says find the maximum number of turning points of each polynomial function. Well, the first one, okay, there's a problem because the first one's not in the right order. So let me get that in the right order. 4x to the 5th minus 3x cubed minus 3x squared. I don't really need these other terms, but I like to write it. Okay, so that's, oh, I've got an extra 3. Sorry, that's not there. Okay, let me rewrite it so it will be accurate. So you want to write these in standard form, so just kind of get in the habit of that. And so the maximum number of turning points, the degree is 5. So that means n is 5. So the maximum number of turning points, TP, is 4. Can't have more than 4 turning points. Now part B, that one's a little bit trickier because you can see, oh, it's not multiplied out. But you know that if you were to square that binomial, now I'm going to keep that negative in front, but if you were to square that binomial, you'd get x squared and then other terms, right? Plus other terms. I don't even care what those other terms are. The second binomial, that's not even in standard form, 2x squared plus 1. Okay, now if I were to multiply x squared times 2x squared, then I would get 2x to the 4th, and then I would continue to multiply, but all those other terms are going to have a smaller degree. Okay, that's going to be my highest degree because I'm writing them in standard form, so I know what, the most I'm going to get. Now if you're like, oh, I don't like this, this is all really confusing, you could just multiply it out. It's not that big. You have, a binomial to multiply, and then you'd have a trinomial times a binomial. It probably wouldn't take you that long. But it's not necessary. We just really need to know what the leading term is. Okay, but because it's negative, it's going to be negative 2x to the 4th, that plus, and then a bunch of stuff. But this is going to be the leading term. So the highest degree here is 4, and that means the maximum number of turning points is 3. Okay, so this is the answer on this.